Okay, so good day everyone, and welcome to another episode of the BJ's Physics Classroom. This time, I'm going to add a little flavor to it so that, the video will be nice, a little bit nice, and then a little bit interactive too. So you can see that this time I'm showing my face. In the previous videos, I haven't shown my face. So if you see me doing that this time, it's because I just want to, maybe I'm maturing in the process of doing the videos. Thank you very much. Today's discussion is going to be based on where we left off, a continuation of where we left off from school. Before we came home, because of the COVID-19, before we came home, we started with thermal physics. And under thermal physics, we began with temperature and its measurement, thermometers. So we just began with quantity of heat, that is measurement of heat, calorimetry, and because of the COVID-19, we had to come home. So this is where I'm going to continue this episode of the physics classroom from. So what that means is that it's basically meant for the Form 2 students, but if you're a Form 3 student, it's a revision for you. And if you're a Form 1 student, remember you may also be writing off deck, so nothing is new under the sun. So take note of that. So our discussion for today is going to be on calorimetry, quantity of heat. So before I begin, please subscribe to my channel, my YouTube channel, so that anytime a video comes up, you get a notification. And then when you subscribe, turn on the notification button so that you receive a notification when a video comes up. Also share the video on the Facebook page or your respective Facebook pages so that people will get it. People will get to see what is happening here. Thank you very much. So let's begin. Okay. So we begin with heat energy. Now when we say heat energy, we also call it calorimetry. Why calorimetry? The term comes from the instrument which is used to measure quantity of heat. We call that instrument calorimeter. Formerly, the unit of heat, quantity of heat or amount of heat a body contains was measured in calories. So calorimeter came calorimetry. Good. So that is the origin of the name calorimetry. So what is heat energy? We define heat energy as a form of energy which flows from one point to another as a result of temperature difference between the 2 points. Good. Let me explain this more. What do we mean by temperature difference between the 2 points? This is, for instance, we have a body having a temperature of 70 degrees Celsius. The environment of the body or the surrounding of the body has a temperature of 20 degrees Celsius. What this means is that the body is going to lose heat to the surrounding because the body has a higher temperature. Remember, heat transfer always starts from a point of high temperature to a point of low temperature. So the body 70 degrees Celsius is going to lose heat to the surrounding. So while the body is losing the heat, the surrounding will be gaining the heat until thermal equilibrium is reached. What is thermal equilibrium? The situation whereby a body has the same amount of temperature as its surrounding. At that point, we say the body is in thermal equilibrium with its surrounding. So whilst the body is losing the heat from 70 degrees Celsius, the environment or the surrounding will be gaining the heat until thermal equilibrium is reached. So that is what we mean by temperature difference between the 2 points. Good. So we have two types of heat energy. We have one, sensible heat, and then two, latent heat. The word sensible here, I know if you haven't met it before, you may be wondering why sensible. The word sensible here does not necessarily mean that, the heat has sense or the heat is intelligent and is able to do things. No. What we mean by the term sensible here is that this is the type of energy that can be felt, the type of energy that you feel it happening. For instance, you heat water from 20 degrees Celsius to 70 degrees Celsius. So you realize that the water becomes hot at 70 degrees Celsius. But it is still water. The temperature has changed from 20 to 70, but it is still water. So that type of heat that the water absorbs, we call it sensible heat. Good. Then the other term is latent heat. Latent heat. Good. The word latent comes from the Latin root, which means hidden. What that means is that this kind of heat is hidden. Good. So let's try and define them. Sensible heat. We define sensible heat as a type of heat that changes the temperature of a body without changing the state of the body. So this type of heat, sensible heat, changes the temperature without changing the state of the body. Good. Then we look at latent heat. We say it is a type of heat that changes the state of a body without changing the temperature. It changes the state of the body without changing the temperature. So let me take an example on this one. The change of state without changing the temperature. For instance, at 0 degrees Celsius, water changes to become ice. At the same 0 degrees Celsius, ice also changes to become water. So when you have ice which is melting at 0 degrees Celsius, it will melt to become water. The same temperature, 0 degrees Celsius, but the water changes state from solid to liquid. That is what we mean by change of state without changing temperature. Good. So let's pick them one by one. This time around we are going to deal with sensible heat. And when we are done with that, we'll then come back to the latent heat and then we'll merge the two of them. We'll look at situations whereby the two of them are happening and how we deal with it. So the quantity of heat absorbed or lost by a body is proportional to the temperature change of the body. So far as sensible heat is concerned, the amount of heat Q, which is absorbed or taken away from the body, is proportional to the temperature difference between the body and the surrounding, or where the body is absorbing the heat from, or where the body is losing the heat to. So from this statement, we get this. Q is proportional to delta T, where delta T is the change in temperature. Q is the amount of heat absorbed or lost. So when we remove the proportionality sign, we introduce a constant C. This constant C, we call it heat capacity. The constant C associated with that material, we call it heat capacity. And we define heat capacity as the quantity of heat energy needed to change the temperature of a body by 1 degree Celsius or 1 Kelvin. Remember, change in temperature is the same, whether degree Celsius or Kelvin. So it can either be per degree Celsius or per Kelvin. You can define heat capacity in words like this. You can also define it using formula like this. Or use the formula C, or you make C the subject in this equation 1. C is equal to Q over delta T. Then you explain the terms where C is the heat capacity, Q is the quantity of heat absorbed or lost, and then, or the quantity of heat contained in the body, then delta T is the change in temperature. So if you define it using this formula, then what you have to do is that you have to explain the terms involved. Now the unit for heat capacity is joule per degree Celsius. You know, joule per degree Celsius or joule per Kelvin. Now, but the heat capacity which is a property of the body absorbing or losing the heat, is also directly proportional to the mass of the body. Yes, the heat capacity is also directly proportional to the mass of the body. So we go through the same principle. C is proportional to M. When we remove the proportionality side, we introduce a constant, and then we get this equation. C is equal to, capital C is equal to small c times M, where capital C is the heat capacity and small c is the specific heat capacity of the body. Specific heat capacity of the body. Remember, the specific heat capacity of a body make use of the mass of the body. The specific capacity of the body makes use of the mass of the body. In dealing, for instance, let me explain this. Let's say we want to determine the amount of heat that the sea can contain. The sea is a big substance that we will not be able to. So to do this, what we do is that we pick a sample, 1 kilogram mass of the sea. Then we look at the quantity of heat that 1 kilogram mass of the sea can absorb. So because we are dealing with just 1 kilogram mass of the sea, we use the specific heat capacity. So the component of the heat capacity that we use for that given mass is the specific heat capacity. That is specific to that particular mass. So that when we multiply it by the mass, we multiply the heat specific capacity by the mass, that will give us, multiply the specific heat capacity by the mass, then that will give us the heat capacity. Good. So we also, when we put this into the equation 1, that gives us Q equals mc delta T. This is the main equation that we use so far as sensible heat is concerned. So anytime you see Q equals C delta T or Q equals mc delta T, we are talking about sensible heat. The unit, we define specific heat capacity as the quantity of heat per unit mass per change in temperature. So you can define it using the formula like this. When you define it using the formula like I stated earlier, you have to explain the terms involved. Or you can also define it in words, that the quantity of heat energy needed to change the temperature of 1 kilogram mass of a body by 1 degree Celsius or 1 Kelvin. The unit for specific heat capacity is joule per kilogram per degree Celsius or joule per kilogram per Kelvin. That is the unit for specific heat capacity. Take note of this. Good. So, quantity of heat. The Q that we saw earlier, which we refer to as the quantity of heat, is the amount of heat energy a body contains. The amount of heat energy that a body can contain inside it is what we refer to as the quantity of heat. The symbol is Q. So anytime I use the symbol Q, so far as this topic is concerned, heat energy is concerned, I'm referring to the quantity of heat absorbed or lost, or the quantity of heat contained in a body. Good. So in summary, the quantity of heat in terms of sensible heat are given as this. Q equals C delta T, where C is the heat capacity. Q equals mc delta T, where C is the specific heat capacity. Q equals mgh. Let me explain this one before we move on. Now, supposing that we position a body in space like this. The body, with respect to the ground, the body has height. So what happens is that when we release the body, at this point the body has potential energy. It possesses maximum potential energy. So when we release this body, the body falls to the ground. Let's assume that the body hits the ground and then all the potential energy is converted to heat. The energy is not converted to sound, it's not converted to any other form, but all the potential energy is converted to heat. What that means is that we get this formula, Q equals mgh. That is the quantity of heat is equal to the mass times gravity times height. That is the maximum potential energy. Then when we use electrical energy to produce heat, then we get Q equals VIT, where V is a voltage, I is current, and T is time. And then we also have Q equals PT, where P is power, electrical power. You know, voltage times current is electrical power. So Q equals PT. That is also another formula for finding the quantity of heat so far as sensible heat is concerned. So factors that affect the quantity of heat contained in the body, we have temperature, size or mass of the body, specific heat capacity or heat capacity of the body, then the nature of surface of the body. Why are we saying temperature but not the change in temperature? We are talking about the quantity of heat contained in the body. So before we began measuring the quantity of heat contained in the body, remember that the body already had a certain amount of heat inside it. In other words, the difference in temperature was from one temperature point to another temperature point. So let's take it that we want to measure the quantity of heat contained in this body. We measure the initial temperature of this body. We measure the initial temperature of this body. So when we measure the initial temperature of this body, that initial temperature may give us, let's say, a value of 10 degrees Celsius. Then we determine the final temperature of the body, let's say 50 degrees Celsius. So the difference in temperature is 40. Remember that 10 degrees Celsius had already put some amount of heat inside the body. So when we are saying the amount of heat contained in the body, which is the Q, it also includes that former heat. Abi, you get the explanation that I'm putting across. Good. That is the reason why we talk about the temperature of the body, but not the change in temperature of the body. So if you write change in temperature, you'll be marked down. Please take note of that. And then when we talk about the nature of surface of the body, we're talking about whether the surface is rough or the surface is smooth or the surface is dull. That is what we mean by nature of surface. Remember that dull surfaces absorb large amount of heat. Shiny surfaces do not absorb large amount of heat. So these are the factors that affect the quantity of heat contained in a body. So let's look at this example. How much heat is given out when a piece of iron metal of mass 80 grams and specific heat capacity 460 joule per kilogram per Kelvin or per degree Celsius cools from 100 degrees Celsius to 40 degrees Celsius. So long as we've been given the mass, we've been given the specific capacity, we've been given the difference in temperature from 100 to 40, it means that the type of heat we are dealing with here is sensible heat. That is very important. When a question is given to you, you should be able to distinguish, or you should be able to determine whether the question is a sensible heat question or it's a latent heat question, or which part of the question is dealing with sensible heat, which part of the question is dealing with latent heat. Good. So this is sensible heat. Okay, so how do we solve it? Solution. We write our formula Q equals mc delta theta. These are the information given to us in the question. So we put the values in. Remember, take note of this. This unit for the specific heat capacity must correlate with the unit of the mass. If the mass is in grams and the specific capacity is also in grams, no problem. Use the mass in grams like that. But if the specific capacity is in kilograms and the mass is in grams, you have to convert the mass to kilograms. The same way, if the mass is in kilograms and the specific capacity is in grams, you have to convert the mass back to grams. Take note of that, please. It is very, very important. If you don't do that, you may have challenges in dealing with it. So we put in the values and then finally we get our solution as our answer as 2208 joules. It means that this is the amount of heat energy the piece of iron metal will lose when it cools from 100 degrees Celsius to 40 degrees Celsius. Example 2. The quantity of heat, 7,500 joules is required to heat brass initially at 26 degrees Celsius to a temperature T. If the mass of the brass is 200 grams, and the specific capacity is 830 joule per kilogram per Kelvin, calculate the temperature T. So the question wants us to find the temperature. Of course, when you look at the information given to us, the question is still talking about sensible heat. So we write our formula, Q equals mc delta T. We have been given the value of Q, that is the amount of heat. So we make T the subject. Remember to convert the unit if the specific capacity is in kilograms. We make T the subject and finally we get 71.18 degrees Celsius. It means that In order to heat brass from 26 degrees Celsius to 71.18 degrees Celsius, we require a amount of heat of 7,500 joules. I hope that is clear. Good. So I want you to take this as assignment. Deal with this question. There are 2 questions there. Be a little bit careful with them. Some of them involve percentage. Take note of that. Answer the question and then go to the Facebook page, look for BJ Physics Classroom, and then post your solution onto the page. I will look at it and I will give you feedback as soon as possible, as soon as I see it. Good. So thank you very much. And once again, please subscribe to my channel, BJ Online on YouTube. Subscribe to my channel, BJ Online on YouTube. And also share the video. Share the video. So this is my YouTube channel, BJ Online. Please subscribe. When you subscribe, turn on the notification button. And then, if you also want online lessons or live online lessons, you can also contact me through this website, www.bjonline.com. That is my own website. When you contact me from there, I can engage you online, and then if you have any question or queries or any contribution, you can also forward it to my email account. That is rjodu@gmail.com. Thank you very much for being part of the show. It's been your man BJ. Hope to see you again with continuation of the heat energy. Thank you very much.